Hello, Geometry. This is my third time trying this recording. Let's see if it works out well. We're going to do two formulas related to the area of a circle. Area of a sector, area of a segment of a circle. Sector first. So a sector of a circle is what you get when you draw two radii in the circle and then you shade one of the portions. You've got a sector over here. One of the two parts of the radii divide the circle into. This over here, more than half the circle, is also a sector. So we've got two sectors here. We're going to get the formula for computing the area of the sector, and it's a straightforward idea. It depends on two things. It depends on this angle here. We need to know this angle here at the middle to get the area, which is the same, if you remember, as the angle number of degrees in this arc. Those are the same value. If this was 130 degrees, and this would be 130 degrees. And so I'll give you either one. And of course you need to know how big the circle is. You need to know the radius. So the formulas, there's a straightforward idea. First you start with the area of the whole circle. That would be if I shaded the whole thing red, not just this portion over here. Just pi r squared. You know that. You know that formula from yesterday. And then we're going to multiply. We're going to take the portion of the circle that we've got here. This angle here is telling us the portion of the circle. Remember, the whole circle, all the way around, is 360 degrees. Or if you prefer, all the way around this angle in the middle, the little circle, is 360 degrees. So if this was, say, 90, that means we would have a right angle in the middle. Then we would have a quarter of the circle. 90 divided by 360 is 1/4. We'd have a quarter of the circle. And so we'd have a quarter of the area in here. And that's how we complete the formula over here. We simply take the whole area of the circle and we multiply by our angle divided by 360, which tells us what fraction of the circle we've got. If A were 90, 90 divided by 360 is 1/4, and so we'd have 1/4 of the area. And so this completes the formula. It's very straightforward. So just to reiterate, the formula is the area of the entire circle times the fraction of the circle that the sector comprises. So that's it. That's that first formula. I want you to try a couple of problems here. So let's get them up. So there they are. This is big U try it. I give you the formula again up at the top. So the first one is I want to know what's the shaded pink area, and I gave you the radius and the angle. And then the second one, I gave you the yellow area. The shaded area is 279 square millimeters to the nearest degree. What's the measure of that indicated arc? So pause for 4 minutes here. Everybody working your tables on this. Take a second if you want to copy the problems down and give these a shot. We'll do a 4-minute pause. Thank you. Alright, so let me go through these now. Hopefully you were able to figure these out. So the first one is you're just plugging numbers into the formula. Formula is up here, pi r squared a over 60. So the radius is 6, so we get pi times 6 squared. The angle is 140 degrees out of 360. Punch all this into a calculator. That's around 44 square inches. Fairly straightforward. Second one's a little trickier. I told you the area. The area is 279. And so that's the area of the sector, 279. And then I have the other side of the formula, pi r squared times a over 360. So that's what I write. I know the radius. The radius is 10. So there's pi r squared, pi times 10 squared. I don't know the a. The angle for that sector is unknown to me. So I have this equation I need to solve for a. So I look over here, I say, okay, I've got pi times 100 divided by 360 times a. So use my calculator. Pi times 100 divided by 360 is 0.8726. So then I have 0.8726 times a. And that is still equal to 279. So I need a by itself. I divide both sides by 0.8726. And that tells me a, 320 degrees. But This doesn't look like 320 degrees, and it's not, because the shaded sector is over here. That's the shaded sector. So A, that we've computed, isn't this angle. It's this one, all the way around there. That's this A, 320 degrees. We want to know this one. But of course, that would just be 360 minus 320. The whole circle is 360 degrees, which is 40 degrees. So hopefully you understood these. I'm going to move on. And yes, I know it looks like Pac-Man. If I were an idiot, I'd try to draw a little ghost or something like that. But my drawing capability is really bad, so I'm not going to do that. Moving on. Area of a segment. So what's a segment? Answer: that's a segment. It's when you draw a chord in a circle, and then you shade the smaller region. I guess this would be a segment too, but I always think of it as this smaller region that's cut off when you draw a chord in the circle. We're going to learn the formula to get this area. And this looks trickier, and it is. It's trickier than a sector. We're going to break it down into two parts. It's going to depend, like before, on the radius of the circle. I've drawn a couple of radii in there. You'll see why in a second. And it's going to depend upon this angle here again, which is the same as the angle in the middle, just like before. And my idea is I'm going to get the area in two steps. The first thing I'm going to do is I'm going to get the area of the sector. You can see here it's the same picture, except I've shaded the entire sector. And then I don't want the whole sector. I want to remove this extra bit that I shaded. And so I'm going to subtract the triangle, the extra part that I shaded. I'm going to subtract that. So if you look here, if I start with the sector, that's what we started off at the beginning of this lecture, and then I subtract this triangle, the orange triangle I shaded, I'll be left with what I want. I'll be left with the area of the segment. So you'll see the formula we're going to generate is going to have something minus something. It's very conceptually straightforward. Sector area minus triangle area. So let's work out what those are. Sector area we just did. So there's the formula again. That's the area of a sector, pi r squared times a over 360. Then we need to subtract the area of this triangle. And here's where one of the formulas we developed last week, which you may remember and you may not, is going to pay off. We had this. Notice that this is an isosceles triangle. Of course, these are both radii. And also notice that this angle here in the middle is the same as this arc measure around this way. If this is a degrees, then this is also a degrees here in the middle. And what we're going to use is we're going to use this formula that we developed last week. You may remember it. If we have two sides of a triangle, oops, where's my arrow? Two sides of a triangle, A and B, and we also know the angle between those two. So we know these two lengths and we know that angle. We have a shortcut formula for getting this shaded area. That was 1/2 AB sine C. 1/2 times the product of these two sides. 1/2 times A times B times the sine of this angle between them. That's the shortcut formula. I'm going to use this down here because I have exactly that situation. I know these two lengths. They're both R. And I know the angle between them. That's A. So 1/2 AB becomes 1/2 AB becomes 1/2 R squared. That's just R times R. Those are my two sides that I know, times the sine of the angle between them, which is just sine A. And that's this orange triangle's area here. And so when we subtract sector area minus triangle area, we get the area of the segment. That's a big messy formula. And it's well worth memorizing because trying to regenerate it on the fly is tricky. So you remember it as, sector area minus triangle area. So I'm going to stop now, and you have some homework that I've assigned to work on these ideas. And I hope you're understanding. Be sure you turn in last night's homework. And have a good day.